Another trip back to one of my favorite graphs, basic stats graphical summary. When we looked at it before, we were more interested in whether the data was normal and what the skewness and kurtosis were. But I also get confidence intervals for mean and standard deviation, also median, in this view. So the quick way to get to confidence intervals without all that math and lookup is to use this graph. So again, it's under basic stats graphical summary, and I get confidence intervals for the mean, the standard deviation, and for the median. So let's take a quick look into how I created the die simulator. There's a couple nice things in Minitab that we can use. So here's the original data that I created, and let's show you how to create the roles here. I'll put it over here in roll number 2. So inside the calc menu, there's a random data pull down, and you can see all of the distributions that we could pull data from. So if you give it the endpoints or the mean and the standard deviation or the shapes, it will give you random data from that distribution. And my first inclination was to go here to uniform, but that will give me not only the integer values, but everything between 1 and 6. And I really want integer values, so I'm going to use this distribution integer right here. And let's see, I generated 4,950 data points, and I want to put it here in my roll 2 data, and I'm going to have values from 1 to 6. So let's hit the OK button, and boom, I get 4,950 random samples just that fast. To create these indicator variables, you go in and again under calc, and this is kind of handy when you have to make indicator variables. Make pattern data a simple set of numbers, and I'm going to put that in 25 at a time. My first value is 1, my last value is 198. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 198. And then I want groups of 25, so each value is going to be there 25 times, and I'm going to do that once. So let's see if that works. I should get 4,950 counts up to 198. I do. So that's how I created the 4s, the 9s, and the 25s and the original data. To calculate the means then, let me go up to the top here. Hit the home key in Minitab to get up to the top of the column. And I've got my roll 25 at a time to create these means here. I'm going to go to basic stats, and instead of going to graphical summary, I can either display them in the window, or in this case I want to plot them, so I'm just going to put them in my worksheet. So I'm going to store my descriptive statistics. It is going to, let's see, I want to, yes, use roll as the data, and then 25 out of, well, I actually want to use roll 2. And then I want to use 25 at a time as my grouping variable. So I will get 198 means of 25. And then under statistics, you can put in all these crazy things. Really, we're just interested in the mean value, so that's what I'm going to ask for. And I think we're all set. It will hopefully put it to the right, but it may fill in one of the empty columns. So let's see what happens. All right, so it did. So we've got the mean, and so this is going to be for 25 at a time, and there are all my values. I should have 198 of them. Yes, in fact I do. So 198 groups of 25, and there are all my means. And now it's pretty simple. I can do histograms. Let's do the descriptive statistics here, so we can get the mean value and all of the confidence intervals and all that good stuff. So basic stats, graphical summary. I'm going to use means 25 at a time. Hit OK, and there we have now our distribution of means. And the standard deviation here is really my standard error of the distribution of means. So 0.32 and 3.5 is my mean. So this little sample data set was even a little closer to 3.5 than my 3.517 for my last 4,950 samples. So that's how I went through and calculated the different distributions using indicator variables here to group them, calculated the means, and then I put together the different histograms. At this point, we've explored sampling error associated with estimating the mean and estimating the variance or standard deviation. But any parameter that we might estimate from data has a corresponding sampling distribution, and a couple of the others that we will use based on some of the hypothesis tests that we are going to conduct would be similar to the chi-square. We're going to look at ratios of variances. So we're going to take one variance, divide it by the other. That follows what's called an F distribution. We'll show you a picture on the next page. And then proportions, those follow a binomial distribution. So if I have a 80% pass or 20% fail, whichever way I want to say that, I can compute the accuracy of my proportion based on, again, my sample size and the binomial distribution. So in all cases, you'll see that by increasing the sample size, my sampling error gets smaller.